Hello everyone, welcome. This video we are going to see interquartile range. So interquartile range, the first thing to note is how to calculate the interquartile range. To calculate interquartile range, we need to do the 75th percentile minus the 25th percentile. So this is the method, the format to calculate the interquartile range. It is 75th percentile minus the 25th percentile. So this is how to calculate interquartile range. Now the question to ask ourselves is how to calculate the 75th percentile and the 25th percentile. Now before we calculate 75th percentile and 25th percentile, you need to put in mind that if you have a straight line in front of you, just a straight line as such, let's say this is a straight line. Now the 25th percentile is splitting that straight line a quarter away from the original point of that straight line. So if you have a straight line as such, this 25th percentile is going to cut through from the origin. Let's say the origin is 7 and the end of that straight line is E. So this is a straight line. Imagine this as a straight line. The 25th percentile is going to cut a quarter away from the origin, which is 7. And the 75th percentile is going to cut a quarter away from the last point, which is 75. So what are we going to do in order to calculate 75th percentile and 25th percentile? So you see from here that since both of them are cutting a quarter away from origin and from the last point, both of them have a similar way of being calculated. Now they are going to be connected by a factor I call factor F, and factor F is calculated as such. Now we said interquartile range 75th percentile minus 25th percentile. Now to calculate each of the percentile, you need to use a factor I call factor F. Now that factor F will be equals to n minus 1 all divided by 4. So this factor is required to split any part of that line. Let's say this is the line. It will use to split any part of this line from 7 to E, any part of this line in a quarter. Now the 25th percentile is a splitting of this line from the origin, and this is, and the 75th percentile is splitting of the line from the end point. So let's continue. So the first thing in our code is to first start to calculate the 25th percentile. But to calculate the 25th percentile, we are required to first start to calculate the factor F. So in order to calculate factor F, I first need to initialize a new variable here as F. So I'll initialize that variable as being an integer type. I'm initializing an integer type because I want that when it is calculated, because when you have n minus 1 divided by 4, it's going to be calculated. When it's going to be calculated, I want to forget about the decimal point and only involve myself with the whole number value. That's why I place it in the value in the integer type. So though factor F is a floating type, I'm going to place in an integer type for me to forget about the integer value. So you have this. In F, I initialize it to 0. So when I have in F initialized to 0, I then move down here. Then I continue by saying, now you have F. I'll say F is equals to, now what is going to be value of F? Let me go back again here. You see that F is equals to n minus 1 all over 4. But we said that in our program, this program, we are using an array, and the array has been declared here. The array has been declared in a certain location somewhere. Yeah, this is the array. So here is the array declared. Now since you have the declared array. This is the array declared here, declared array. Since you have the declared array here is going to, the declared array here is containing the different values of the variable that you want, that they want the owner to the user to enter into your code. So in this array, you see that the first term in an array is not 1, is not represented as being 1, but the first term is represented as being 0. So it implies indirectly that the last term it will not be n in terms of array, but it will be n minus 1. So what I'll come out and do is that instead of using directly this formula n minus 1 all over 4, I will use n minus into all minus 1 divided by 4. So I have n minus 1 minus 1. N minus 1 minus 1 is n minus 2. So n minus 2, I'm going to divide it by 4 in order to have factor f in terms of array format. So I'm going to have n minus 2 divided by 4. No, not here. Remove it here. I come down here. I place n minus 2 divided by 2. So I have it. N minus 2 divided by 2. This factor will be the factor that's going to split this series. Let's say the series is a series of edges. You want to split it in quarters from the original point and from the end point. You want to split it. When you want to split it, we are going to have the arrays. We are going to have factor f equals to n minus 2 all divided by 2, all divided by 4 instead. It's 4 because the denominator was 4 in this last part, 4. Now after having it, I'll store the variable. Now I'll store about that value inside integer type, so it's going to forget about the decimal point that's going to be formed. So when I have this, I'll now find for the 25th interquartile, 25th percentile instead, or the first quartile, 25th percentile slash 25th percentile or first quartile. So if I find the 25th percentile first quartile, this line. Now I go below. How will I find the 25th percentile? So in order to calculate the 25th percentile, you are first required to know that the first term in the array format is starting from 0. We initially said that the first term starts from 0 and the last term is at n minus 1. So it implies that when you have the first the 25th quartile is going to split from the first one. The first one starts from 0, so the position of the 25th quartile will be actually 0 plus f. So this is the position of the 5th quartile. So that position is actually f. So now when you have the position as being f, you'll see that the value of the 25th quartile is lying between the location f, the variable f, and that of variable f plus 1 by a factor of 0.25 from the original point of variable f. So this, you are going to know this when you are going to study much more statistics. So you need a bit more knowledge on statistics for you to understand this point. For us to have the interquartile range at this point, the 25th percentile at this point, we need to take the initial point. Initial point is the 0th term. The 0th term now plus the point at which we want to cut it the quarter, we add it. So we see that it's the 25% that's going to be located at the f term, and between the f term and the f plus 1 term. Now it's going to be located. You see that the 0% is going to be located between the f. From here we see that it's located between the f term and the f plus 1 term. So this is the location of our of our percentile. So the location is given as such of our 25th percentile. Location is between the f term equals to location equals to between the f term and f minus 1 term. So now in order for us to calculate the 25th percentile, we need now to find for f term f minus 1 term and multiply by a factor. We're going to multiply by a factor of 0.25 because it is 25th percentile. In case of the 75th percentile, we are multiplying by a factor of 0.75 when we are finding this range in the location. Now, let's come to calculate now for the 25th percentile. We are first going to calculate another value which I'm going to call location, or instead, so we are going to calculate now a variable I'm going to call location. So I need first to initialize that variable here. So I'll say float location. No, location is already set in the program, so I will say float and use another word, let's say 20 feet. We cannot use the numbers, so we say location 25. So this location 25 is going to be the location for the 25th percentile. We cannot place 25 at the beginning. I wanted to say 25th location, but in C programming, it is not allowed to name a variable with numbers starting. So you can place number in between as such. So I'll initialize it as 0. So I then come down. I say now that location 20 feet will be equals to location 20 feet now is equals to, I'm going to find the range of the variable. So it's variable f plus 1. So I'll write here f plus 1. I'll now subtract minus variable. No, it's not in bracket but in square brackets here. So variable f plus 1 and variable into f here. Then I come here and I multiply all of them. When you want to do multiplication in C programming, it is done with the asterisk sign. Multiply all of them times 0.25. So I multiply all of them times 0.25 and then go. So this is going to, I'm going from this location 25, you're going to give me the location of my variable between the f term and the f plus 1 term. So now in order to know the 25th percentile, I'm now going to create another variable here. So my variable will be called float here, percentile 25th. Again, in C programming does not allow you to start with numbers at the beginning of variable names. So I have this equals to 0. You go on the equals to 0 and then you put your semicolon. Now when you have this float 25th percentile, you can now come again and calculate now for the 25th percentile. So I'll write here percentile 25th is equals to, what will it be equals to? It will be equals to the variable f plus now this location 25. So I'll write variable f variable, yes, into f now plus location 25 as such. Now this is going to be the value of my 25th percentile. Yeah. So now this will show the value of my 25th percentile and I can print it directly. So I will say print f the value of the 25th percentile is 2 dot. In order to place it out, I know that the 25th percentile is stored within a floating point. Since the 25th percentile is stored within the floating point, I'm going to bring here a percentage f and then come here and then I'll call percentile 25th. Yeah, I'm going to come and be taking the position. Now I want that this is day, then I want that it goes on another line, one line on itself, then it takes again, goes another line on itself, then it taps and it taps. It should be aligned with the others above. Now you have this. This is to calculate the 25th percentile. Now to calculate now for the 75th percentile is similar, but in this case you're instead going to find the location from the last term. So here is 75th percentile. So 70 percentile, how will you do? You still have the same format as this one. You still have the same format as this one. Now we are going to the 75th percentile is going to be located. So now you need to calculate the term that is going to the term in between which the 75th percentile is located. So in order to do this, we initially said that if you consider this 75th percentile, this line here as being this phrase here as being a line, let's say 70th percentile as being a line, realize that we have a red line here. Realize that the initial point, the factor f is getting a quarter for the 25th percentile. Factor f is going to get from the initial point to a quarter here. Now for the 75th percentile to be calculated, the factor f is going to get from this initial point and now to this point here. So it's going to get all through as such. Factor f is going to get all through as such, and the location 70th percentile is going to be located here. So the first thing that we are going to do in order to calculate here is to find for the term in between which the 75th percentile is located. Now to find for that, we are going to do the last term minus the f factor. So, and we said initially that in case of arrays, the last term is considered as being n minus 1. So now we come back and say that, so you have to declare the position in the terms in between which the variable is going to be located. The 70% is going to be located. So I'm going to declare it as being an integer type. So we declare as integer type. We say L. So we write it L75th. So L75th as such. So it is L here and 75th, not 1. So we write L75th like this. Now when we have this, we can now go and say that in this position the L75th will be equals to, I say it is the last term. The last term in case of array is n minus 1. So last term minus, I come here, I take the factor f minus factor f is going to give me the terms in between they are going to be located. So now I'm going to now find again another factor, location 75 now. So I'm going to create another array variable, location 75, which is going to be similar to location 25 in this case. So I have floating point location. I'll create location. In this case, it's inside going to be 75 is equals to, I initialize it to 0. Now I have location 75 here. I will say now here that that location 75 here will be equals to I will take now I'll say that it will be equals to the variable, the location. Since I've found this one, I'll know that it is going to be contained between variable health and variable health minus 1. So to find that location, I'm going to do this variable this, and then I place square bracket. This is health minus 1, and then I come out, I say it is between it, so I'm going to add up. No, I'm going to instead subtract it up. I'm going to subtract it with, so it is variable health minus variable into health, yeah, this minus 1 as such. Now I will multiply now instead. Now the factor for 70th percentile is not 0.25 but 0.75. So I'll multiply now by the factor 0.75 as such. Go on the next line, come down. Now I'll now create another value which is now going to contain actually the 25th percentile, the 75th percentile. So I'll create again another variable here of floating type, call this floating type percentile. So percentile, here I'm going to put 75th. I initialize it to 0. Again, I told you that in order to write names or variable names in C does not allow you to start variable names with numbers, else an error is going to should be shown on the debugger. This is the debugger down here. An error is going to be shown on it. So you come here, you have times this, and lastly you have percentile 75th as such is going to be equals to, I have percentile 75th. Now I know that it's going to be located, is going to be located 0.75 away from the first term. You know that the first term between the term which comes first between this term and this term is this one. It's going to be located away by this location from this first term. So I'm going to write percentile that is going to be variable. So variable into health, the health term minus 1. I come here now, loss location 75 instead. Now when I have the value, I'll do a similar thing with printing of this. I'll cut, no, not cut, but copy. I'll copy this, and then I come and I paste here. Now I'll remove all this end. I'll just say to go one line below. Then I have this. Then lastly, we are required to calculate for the interquartile range. So interquartile range, I can call it interquartile range. I'll just call it IR. So interquartile range IR is equals to, the interquartile range IR will be equals to the percentile 75th minus percentile 25th as such. So now I've written interquartile range here, but I haven't declared interquartile range in the question. So I'll come above here and I'll say that there is an interquartile range which exists. That interquartile range will exist as a floating type. So we have, I'll call it IR. I declared as IR as such, and I initialize the value, and I told you to always initialize the value with 0. So when initialize, you come down here, you have interquartile range. Now you print again I ask you to print again the interquartile range. I copy. So here I first replace here with 75th percentile, 70th percentile, and now I come and replace here with 75th percentile. When I come here, I copy this, then I come down here and then I paste. It goes now. I want it to go to that times down. I write this formula. I want to write this formula in the equation, so I'm going to do this. Good. Then I'm going to place this formula in, copy, then write inside it, paste, and say it is equals to this. So I have interquartile range equals to 70 percentile, or I can write here inside 75th percentile. So 75th percentile, because this is what will be shown to the user, minus 25th percentile. Now equals to this value, equals to this, and then I come out with the interquartile range IR. I prefer calling it interquartile range. So I'm going to arrange that name back here, so it will be called interquartile range. So you have this interquartile range, this one is still interquartile range, and so I'll arrange this one to interquartile range. So that's what I want. So this one, I remove this capital letter here as such. So this is the end of the program. So this, from here we have all the program in order to calculate the 25th percentile. It starts from here, start from factor F, then you go to 25th percentile. After 25th percentile, go to 75th percentile calculation, and then interquartile range calculation. So here is interquartile range. Now let's see how we execute the program. First compile, and then some errors are being shown to us. So error variable, because we didn't spell it very well. So the next error here is interquartile range undeclared. So interquartile range undeclared on which line? Line 103. So this isn't the name that it knows. So I'll start again, because when you do a small error with the name, then there's a problem. So interquartile range undeclared. Now the next error, no major error again. I compile, so no error is shown again. Then I run. Then I compile and run. I come, enter the total number of variables. Let's say I want to enter a total number of variables. I have 5 variables I want to enter. Now enter all the variables of data analysis below. So my first variable I want to enter is, I want that there is 0, I want that there is 3, I want that there is 2, I want that there is 1, and I want that there is 4. They are 1, 2, 3, 4, 5. I enter, I see the ordered series is 0. You have 0 first, you have 1, you have 2, you have 3, you have 4. The median is 2. From here we see that the median is 2. The range is 4 minus 0 is 4. The value of the 25th percentile, the value of 25th percentile is here, and the value of the 70th percentile is here. So when seeing the code above, we see that there's a small error on the 25th percentile and the 75th percentile. This is because normally the 25th percentile in this case is supposed to be 1, because 1 is going to split it into quarter. From 0 to 4 is going to split it here. So the 25th percentile is normally equals to 1, and the 75th percentile normally in this case is supposed to be 3. But here we have this error. This is because it is considering in cases where 4 is not divisible by is not a whole number. If the total number of terms is not a whole number division of 4, then the values are going to, the code above is going to be correct. But now when you are going to 5 minus 1, 5 minus 1 is going to give 4. 4 divided by 4 is going to give a whole number division. So now it's required now to go now back to the code and to arrange it such that we include when it is divisible by 4. In this case, like in this case. So now let's come back again. You see that this part, all what we've calculated here from factor f to all that is in case when it is divisible by 4. So I will start here by writing an if loop, an if statement. It's in case when it's not divisible by 4. I write if the factor f. So we are going to say that in this case, if n minus 1, to consider factor f, if n minus 1 we do the modulo of 4, if n minus 1 mod 4 now is not equals to 0, then it will proceed through all the steps you have written. So you are going to write and cancel this. Now come down, write interquartile range, all this. So I'll write all the values and cut all this through. I cut this and I will paste down here. Then I will come here again. I cut this and then I will come and paste it down here. So all these values are going to be contained inside that if loop we have created initially. So all this is in case when it is divisible, it's not divisible by 4. Now if it is divisible by 4, n minus 1 is divisible by 4, we say if now n minus 1 is divisible by 4, so we write, I place again here, if n minus 1 now, n minus 1, I write the mode of 4, it gives actually 0. So what happened? I now enter into a new code. Now in this new code, I'm going to calculate now for a new value for the location of 25 and this. So in this case, when it is, because in the initial one we had, we saw that 4 divided by 4 gave 1, and the normal was supposed to be at that position 1, so at the first term. So now if now in this case n minus 1 is visible, we are going to enter now and say percentile 25 first will be equals to, so it will be equals to variable in bracket f as such. Also we are going to say percentile now 75 here is going to be equals to now it's not more, this will be equals to variable f, or it will be equals to variable 0 plus f. This is because 0 in the variable type is the first term, so it's variable 0 plus f. Now in case of the 75th percentile, it will instead be the last term in the variable, so it will be variable into, I put it now the last term, I know that the last term will be n minus 1 in case of arrays, so n minus 1, and now I'm going to place minus f, so it's exactly going to be at this location. I then come out and I do this, so the interquartile range will remain the same. This is why I'm going to cut it from this loop and I'm going to place it out of both. So I'm going to have the interquartile range here, I paste it here. So this is our new code in order to don't have no error with the problem, to solve the problem that we've seen above. So let's try and execute So the problem comes here. It's telling me variable is undeclared. This is because I didn't spell well variable. So I compile, no error is shown to me, and then I run. So I'll still do the same code. I have 5 terms. One of my terms is 0, 1 is 2, 1 is 1, 1 is 3, and 1 is 4. What do I realize? I realize that the order series is 0, 1, 4, 3, 4. Now, but in this case now, so the median here is 2, the range is 4. Here the 75% has been taken as 4, and in this case 0. So let's see very well. If you do 4 minus, you have 5 minus 4 is the end term. 5 minus 4 is end term. We have is going to give 1. So to arrange the code, I'm going to place here this. I'm going to change slightly this, and then copy. I'm going to come here and write paste here, then change this 1, and then like this 4. So let's try again to execute the code, compile and run. So we have this. Let's say we enter again 5 numbers. The numbers are going to be 0, 3, 2, 1, and 4. So now in this case, you have exactly what I said. So we have ordered series. When it is even number, ordered series, you have 0.0 this 1 that the median is 2.0, the range is 4.0, the value of the 25th percentile is 1.0, the value of the 70th percentile is this, and interquartile range is that. So this is actually a true program. So now let's test when the number of variable is not more an odd number but an even number. So this is in case where the number of variable is an odd number and is an even number and it's divisible, the subtraction is divisible by 1. Now let's try to see the other cases. So we compile and run. Let's say we have insert here 7 numbers. Now when you have 7 numbers, I'll enter one number, second number, third number, fourth number, fifth number, sixth number, seventh number. So these are the 7th number. I enter it. So the order system is 1.0, 2.0, 3.0, 3.26. Now we have the median is 3, the range 6 minus 1, 5. The interquartile range is 2.25, and the 7th percentile is 4.75, and we have the 75th percentile given as such. So from there, we have seen how to calculate the interquartile range using a code of 117 line, including the median. So this program will calculate the median, the mean, the interquartile range, the median, the interquartile range, and lastly the range. So from here we'll say thanks for your kind attention.